Hello everyone, my name is Pang Chungtai and my group members are Marcus Hamkaiser and Wong Zikai. So today I'm going to present our project, an IoT-based retail customer flow counter. This is a smart system designed to help store owners count how many people enter and exit their shop in real time. Okay, first let's we talk about the problem in retail. Many small store owners do not know exactly how many people visit their shop every day. They try to guess their business hour based on sales numbers, but sales do not tell the full story. Owners often make bad choices like hiring too many staff when it is quiet or too few staff when it's busy, leading to long lines and unhappy customers. Okay. To solve this problem, we, we create an IoT customer flow counter. We place smart hardware sensors right at the store entrance to automatically detect whenever a person walks in or out. The data is sent instantly over Wi-Fi to a cloud platform, so the store manager can see live traffic charts right on their mobile phone or computer. This is our data flow diagram DFD, showing how information travels through the system. First, when a customer closes the door, the sensor sends a trigger signal to process one. Process one figures out the direction and updates the current count database. Next, process two checks the counts against the safety limits. If the store gets too full, it sends a batch red capacity alert to the manager. Finally, process number three, save this data over time to build long-term traffic reports. Yes. For our for our communication protocols layer, we choose Wi-Fi and MQTT. We choose Wi-Fi because almost every retail store already has a Wi-Fi network, and our device plugs into the wall, so the power consumption is not an issue. We choose MQTT because it is lightweight. Instead of sending large files, it only sends tiny text updates like +1 or -1. This makes the application updates real time with zero lag. Next, we build a real physical prototype prototype instead of a simulation because real world factors like sunlight or shadows need to be tested. We use an ESP32 microcontroller board because it is cheap and has built-in Wi-Fi. For the software interface, we use platforms like BLYK or Node-RED, which allow us to build a beautiful and clean user dashboard without coding an entire mobile application from scratch. All right. Our system brings our system brings huge benefits. Store owners will know exactly when their peak rush hours are so then they can schedule the perfect amount of staff. They can measure if a weekend sales actually brought in more foot traffic. Most important, most importantly, it cuts down customer wait times, creates a better shopping experience, and stays affordable for small business owners. That's all for my presentation. I'll pass to the next person.
Good morning, everyone. I will be presenting part 3 which focuses on the implementation and data analysis of our retail store customer flow counter. So since this project is a proof of concept, we use Cisco Packet Tracer to simulate the proposed IoT system. The, uh, the impl- and the implementation demonstrates how customer movement can be detected, monitored, and visualized using IoT technologies. So figure 1 shows our Cisco Packet Tracer topology. Two motion sensors are placed at the entrance and exit of the store to detect customer movement. And the home gateway acts as the central IoT controller, allowing all devices to communicate over wireless network. And a monitoring PC is used to observe the system, while the smart light represents the store full indicator whenever the maximum occupancy limit is reached. So figure 2 shows the wireless configuration of the home gateway. The configured SSID allows all IoT devices to connect to the same network and exchange information in real time. So in figure 3 presents a sample dashboard generated from the simulated customer data. The dashboard displays the current occupancy together with the total number of customer entries and exits. And the line chart illustrates how customer occupancy changes throughout the day. And from the graph, managers can easily identify peak shopping hours and monitor customer traffic patterns. So the collected customer flow data provides useful information for our store managers by identifying peak shopping hours, and managers can schedule more staff during busy periods and reduce staffing during quieter hours. The data can also be used to evaluate whether marketing campaigns successfully increase customer traffic. And in addition, the occupancy count helps prevent overcrowding by activating the store full indicator when the store reaches its maximum capacity. So overall, this system enables retail stores to make informed decisions using real-time customer traffic data instead of relying on estimation. And that is for my part. Thank you.
My name is Beckham Wong, and I will be presenting the critical analysis and conclusion for our retail store customer flow counter project. While the previous speakers have shown you how the system works, I will now walk you through the real-world challenge we identify, how we plan to secure and scale this system, and the exciting future enhancement we propose. First, let's look at the challenge. We categorize this into three main areas. On the technical side, we identify two major handles. The first is occultation. Since we rely on a simple IR beam break logic, if two customers walk through the door side by side, the beam only breaks once. This causes an undercount. The second is network latency. As we rely on Wi-Fi and MQTT, any instability or outage in the store router will freeze the live dashboard until the connection returns. For the hardware setup, we face practical constraints. We have to mount these industrial sensors and enclosure without running the store aesthetic appeal. Routing power cable for that 24 per 7 continuous operation also limit where we can physically place the sensors. And finally, the operational gap. This is a critical human element. The technology can detect that the store is full and trigger the warning light, but staff must still physically intervene to politely stop customer at the door. This is a human management challenge that our system cannot solve alone. Moving on to scalability and security. For scalability, this system is incredibly flexible. For multi-entrance doors, we can simply add more MQTT sensors nodes to secondary doors, and the cloud will seamlessly aggregate all the data into a single unified occupancy account. For enterprise-level deployment, a centralized cloud hub allows regional managers to monitor over 50 different branches simultaneously from just one login. For security, we propose a defense-in-deep approach. First, WPA3 encryption to harden the local gateway and prevent packet sneezing. Second, we will implement TLS threat SSL encrypted payloads for all data traveling from the ESP32 to the cloud, ensuring store traffic statistics cannot be intercepted or tampered with. Looking to the future, we have three realistic enhancements that build directly on our current design. First, RFID interaction. To solve the object confusion issue, we can give employees RFID badge. When a staff member blacks the beam, the system reads their tag and automatically ignore that entry, ensuring our data reflects only true paying customers. Second, predictive AI. By feeding our historical traffic logs into a machine learning model, the dashboard could move beyond showing past data to accurately predict future peak hours weeks in advance. This allows managers to build highly accurate staff schedules. Third, automated access control. Instead of just flashing a warning light, we can link the system directly to automated sliding doors or turnstiles. Only capacity is reached, the microcontroller will physically prevent the doors from opening, removing the need for manual staff intervention entirely. To conclude, our retail store customer flow counter successfully bridged the gap between raw hardware sensing and actionable business intelligence. By layering in ESP32, MQTT, and cloud virtualization, we have replaced retail guesswork with verified real-time data flow. The key lesson we learned in that the true value of IoT lies not just in the hardware, but in the seamless interaction of edge sensors, secure network protocols, and user-friendly dashboard to drive smarter, data-driven business decision. So that's conclude my part of the presentation. So thank you for your time.